Hello friends, in this playlist we are talking about building enterprise data warehouse using Hadoop ecosystem, and so far we have covered uh, uh, overview of what we are going to do, and then we started with the agenda. We have completed a Hive architecture, and we have covered theoretical part of Hive DDL. Today we will be doing demo, or in this video we will be doing demo on Hive DDL. Okay, as I have mentioned in my last video, these are the things which you need to keep in mind while creating tables or while doing the physical data modeling in Hive. So first we need to think about the data types. The data types are different between conventional databases and Hive. So you need to understand the differences of them. So for example, character is represented as string in Hive, whereas in conventional relational databases, there are char, varchar to club with precisions, whereas in Hive there is no precisions. Similarly, while creating the tables, we need to think about file and line delimiters. We have to think about file formats. We have to determine whether we want to create external table or managed table, which I have explained. The difference is being explained in the last video. And we can create partition tables or non-partition tables. We can use CTAS to create table out of a query, and then we can actually see the properties using describe command, and also we can actually create a view. So today, sorry, as part of this video, I will be doing a demo of most of this stuff. And while doing the physical data modeling, we have to keep these things in mind. We have to think about file formats, change the data types, delimiters. We might have to consider redundancy as one of the top design strategy because of the details which I have covered in my previous video. We have to determine whether partitioning is required or bucketing is required, and we should keep in mind about too much partitioning versus too little partitioning. So let's go on to the demo. Uh, Let me commit the code. In GitHub, and I'm syncing it. And now I'm going to Cloudera VM. This is my Hive prompt. Okay, and um, this is my GitHub account. Code Hadoop. In my GitHub account, if you go to code repository and click on Hadoop, you will see a directory called EW and Hive, and in that you can see the demo file. Okay, I need to delete this swap file. I will delete it later anyway. So now, if you see, first let us see how we can create a managed table or a external table, sample managed table and external table. I have already created deck of cards in the database called cards. So first I have created a database called cards, and I have created deck of cards table, and I have dropped as well. So let me start from scratch now. Drop database cards. So if you want to drop the database, you can use the drop command, and database have to be empty so that it can actually drop the database. So first I'm creating this sample. We are not in ODS yet. I just want to show you simple commands, and then we will actually create the tables for our data warehouse. I'm pasting the commands. So database is created. You can run show databases command, and you can see cards. You can say use cards, and then you can run this command to create the table. It is and if you want to see the details of the table, you can run describe command like this, and describe command will only give the column names and data types. Whereas if you run describe formatted deck of cards, it will give a lot more details about the actual properties of the tables as well, not just column names and data type. It starts with column name and data type, then it will give more further details about the table. It will this is the database name. Owner is Cloudera, so this database is actually owned by OS user Cloudera. And then this is one of the important information, the location of the table itself. So as I have explained in the last video, when we create the database under user Hive warehouse, a directory with .db extension will be created with the name we have used while creating the database. And then when we actually create the table, a directory will be created under the database under which we are trying to create the table. So cards.db is the directory for the database, and as we are trying to create the table under cards database, there is a directory created with the name which we have given at the as part of create table command. And then if it is a match, the table type will tell whether it is a match table and external table. If you want to if you could not remember the difference between match and external table, go back to the previous video and you will be able to figure out the difference. And then Hive uses this serialization, so Serde library. So now we are talking about the storage information. As part of the storage information, it will tell what is input format, what is output format. Those are the more important information than any other thing here. Depending upon what we have specified in the stored as clause. So in this case, we have specified stored as text file. So if it is text file, the file format will be text input format, which means that when Hive tries to read the data, it will read it as a text format. If it is sequence file, it will read it as a binary. So depending upon the format, it will determine how to read the underlying files. And the output format is Hive ignore key text output format. So if you are familiar with the input formats and output formats in MapReduce, for input format it is using MapReduce input format, but output format it is using Hive custom output format. Then the field delimiters is pipe. So we have defined as part of the create table command. So here we are telling that each field in each row should be delimited by pipe. So that is what it is showing here. Okay, and then the first one, serialization deserialization library. So when you actually create a table to read the data, we need to have serialization deserialization framework, and Hive uses this lazy simple serialization deserialization class to read the data. You need not worry much about it. As a developer, if you are planning to use Hive for your enterprise data warehouse, you need to focus more on this stored as clause. And in some cases, you might have to define Serde. You need not understand the internal details of Serde, but you need to keep in mind that if you want to use custom input formats, then you have to start with Serde and then input format, and you should define table accordingly. I will show you an example for that later. When we actually create the stage table, we use different type of Sardes and all those things, and it will become clear at that time. For now, we will use default out of the box formats. So in this case, we are using text file. And once the table is created, we will copy the data. So you can run this query. So if you are following this exercise, if you have to download the if you want to test the script, first you have to connect to my repository. There under data, there is a directory called cards, and in that there is a file called deck of cards.txt. You can actually copy data from there and place it in a file under this path on your VM, home Cloudera demo data cards. So you have to create the directory like this, and then you have to create a file deck of cards.txt and copy the content of the files from the GitHub into that, and then you can actually run this command after the table is created. Okay, so let me paste it here and hit enter. So now the data is being copied, and now you can actually run a query to validate whether data is copied successfully or not. So for that you can say select star from deck of cards limit 10, and you can see the data. Okay, and now if you have to create an external table, you have to use this one. The main difference between the main syntactical difference between managed table and external table is external table have additional clause in create table called external, and also you have to specify the location. Without specifying the location, it will not be able to figure out from where data has to be read, and it will error out. Those two are the major differences when it comes to syntax. I have explained the functional differences in the previous video, so you can watch it if you could not recollect the functional differences. Not. So the create table command failed because of the syntax error, and this location should be at the end. So let me commit that. Okay, I'm syncing it, and now let me go back here. Let me refresh this, and this is the right syntax. And now I'm running the command. So table is external table is created. If you see, I am giving the same path which I have used for my managed table, so that I don't need to I need not I don't need to copy the same file to a different location. Typically this will not be the case. External tables and managed tables will not be pointing to the same location, but just for demo purpose I am pointing it. So you can run describe formatted, and you can give the table name. Shit. Come on. Copy, paste. Okay, so if you see here, it is saying it's an external table. Rest of the stuff is almost same. To validate whether it is working, whether we can read the data or not, you can run this query limit 10, and you can see the data. So this is about managed table and external table creation. Now we will actually start creating the ODS database, and we will actually do the physical model for all our tables. So before getting into it, let me explain about the current data model, which is in MySQL. So these are the tables, and what I want to do is, using this information, I want to see the performance of my products and the categories as well as the departments. So I want to start at product level. I want to see performance of my products as part of the sales, and then products are categorized into multiple categories, and from products I want to roll up into categories and see the performance of each category, and from there I want to see the performance of the department as well. So let me so to go to the department, I have to join order items, with products, categories, and departments. Then only I will be able to see at department level. So I have to join 4 tables. Okay, so the query will look like this to get the performance of my departments. So the query will look like this. So I'm joining all the 4 tables. Let me expand it further. Now if you see, I'm joining departments with categories, with products, with order items, and then I can see how my departments are performing. So fan shop is the one which is actually having most number of sales when it by amount compared to any other department. So I want to generate these kinds of report, and if you now the queries were pretty fast even in on a small MySQL database, because we have only a few thousands to few hundreds of thousands of records in these tables. But in a typical production scenario for a large client, these tables can be pretty huge, and you cannot actually run these complex queries on your transactional systems. You have to move it to enterprise data warehouse. And as I have explained the relevance of ODS, you have to even create the ODS. And when it comes to ODS, the data model looks similar. So the table structures will be almost similar between the source MySQL database and the ODS Hive database, target Hive ODS database. So first let us see the tables here in MySQL. There are 6 tables: categories, customers, departments, order items, orders, and products. Order count by city is created by me, so just ignore it. Uh, you can if you map this with the data model which Cloudera has published, you can see there are 6 tables, and all the 6 tables are available in MySQL database called RetailDB, which is part of the Cloudera virtual machine itself. So let us describe a table first. Describe categories. There are 3 columns: category ID, category department ID, and category name. And for the report requirement which I have shown earlier, uh, we need at least 4 tables. The 4 tables are order items, products, categories, and departments. If you have these 4 tables in ODS, you can actually generate the report. And order items and orders are very tightly coupled, and these 2 are the transaction tables in the system. All the other 4 are not transactional tables. Only orders and order items are transactional tables, and they will be pretty huge, and they are tightly coupled as well. So as I am getting order items, I have to have orders also, because it might make more sense to include both of them to get the reports like what I have explained earlier. So for that reason, we have to create for at least 5 tables in our ODS. In this case, I am creating all the 6 tables in ODS. And first, let me show you the translation of the data types. Okay, so when I describe this table in MySQL, the data types are int, and varchar. Whereas when I actually create categories table, sorry, this should be customers. Let me do that. Okay. Okay, now let me refresh this one. So first is the categories. Categories on the source are integer, and varchar of 45. Whereas here, when we actually have to create the table in Hive, we have to define the category name as string, because all the character types are represented as string. So let us create this table. So before that, let's create the database. I think database is already there, but you can run this. It will create if the database does not exist. If the database exists, it will just ignore. So then we have to switch to retail ODS database. So you can run this query, run this command, and now you are in the retail ODS database. And first let us see what is there in retail ODS as of now. DFS ls user hive warehouse, or I can actually run show tables command. So there are no tables at all, and also we will validate from the file system whether there are any tables. User hive warehouse retail ods.db. So there are no tables here. Now we will start creating the tables. So table is created, and now let us see. Now categories directory is created because the table name is categories. You can run describe formatted categories to see the properties of the table. So similarly, we will create customers table. So these are all standard tables. And departments. So we are not copying the data yet. Data integration part will come later, and we will talk about loading data and all those things at that time. So at this time we are only modeling the tables. Now comes orders table. So if you compare the other create table commands and this table command, there are two things which might catch your eye. First one is order date, which is defined as string. As I have explained, there is no date data type in Hive, so all the dates have to be represented as string. So that's where I am actually changing the data type to string here. And then as orders and order items are very large tables, can be very large tables in major retail clients. Instead of storing as a normal table, I want to partition. And when I decide to partition, first thing that needs to come to your mind is too much. It should not be too much partitioning, or it should not be too little partitioning. You have to understand your data characteristics, and based upon that, you should determine your partition criteria. So in this case, I felt that order month might be a good partitioning strategy. Even for the moderate sized client, monthly data will be in few gigabytes when it comes to orders at the max. So I felt order by month might be a good decision. That's why I'm trying to create table using partitioning by order month. Okay, and this is the list partitioning. So there are only two types of partitioning in Hive. One is list, second one is hash or bucketing. There is no range partitioning. So I am copying this one and creating this table. And if you actually describe orders here, there is a date which is of type date time, but we are storing it as string in Hive. Now we will see order items. Okay, and order items, if you see, there is the order item ID, order ID, product ID, quantity, subtotal, and product price. So order item have the foreign key to order ID in orders. So order item order ID is the foreign key for order ID in orders. Okay, so these two are the tightly coupled tables. So order items will have all the items that is placed in each order. So when you go to a website like Amazon, if you place 10 orders, the order level detail will be there in orders, and the actual 10 items will be there in order items. So there is a very tight relationship between these two tables, orders and order items. So now if you see the Hive create table command, I have included order item, order date as well. The reason is, as I mentioned to you, these tables can be huge, and you should partition. You should consider partitioning when you actually copy these tables into Hive. And as orders and order items are tightly coupled, if they partitioned on the same key, the performance of the queries will be much better. If I partition orders based on order date, and if I partition order items based on something else, then when I join these tables, there is a term called partition pruning, where only related partitions will be scanned and unrelated partitions will be eliminated, which will not work. And it has to do full table joins on both the tables orders and order items, which is not good for most of the cases. For that reason, I have introduced the additional column, which is called as order item order date. This column will be sourced from orders, so it is a little bit of denormalized structure even in ODS. And then I'm trying to use the same same clause to partition my table, which is order month. So there is a little bit deviation from the source system, and the target order items in the source table, source database, and the order items table in the target Hive database. Even though it's ODS, because to leverage the partition to run my joins more effectively, I have to do this. If you think about implementing the same ODS in traditional databases like Oracle, you need not do this, because you can create the indexes, and in most of the cases they will perform very well. But in Hive, as the indexes are not very well supported, you have to come up with more sophisticated solutions using the features that are available. You have to think through the problem and come up with a solution, effective solution, uh, like adding order item order date to order items. And when you actually insert data into order items in your ODS, you have to source order date from your orders table using by joining order item order ID and order ID on regular basis while loading into order items. And then you can actually join orders and order items not only on order ID but also on order month, so that partition pruning occurs in the downstream for the downstream process. Okay, so this is a very important design criteria which can give you a lot of benefits when you actually start implementing your data warehousing using Hadoop ecosystem. So this is where I am highlighting the redundancy portion of it. So you should think the redundancy as one of the important design criteria when you actually do physical data modeling in Hive. Okay, now let us create this table as well. And if you want to create a bucketing table, so for some reason, instead of using date as partitioning criteria, if you want to partition with something like order ID, which is mostly unique, which will be unique in orders table, and a very sparse field even in order items. When I say sparse, if there are 100,000 orders, and if on average there are five items placed in that order, there will be 500,000 order items, and order IDs will still be 100,000. So you can actually do hash partitioning on order ID, and in most of the cases you will join orders and order items on order ID itself, so the performance will be good. So let me rename with a different different tables, because I have already created orders and order items, so I should now use a different table bucket. let me name it as bucket itself. So this is these two create table commands are examples of bucketing, which is nothing but hash partitioning. So in this case, we are actually clustering the order ID into 16 buckets. So if there are 100,000 orders, those 100,000 orders will be distributed into 16 buckets using hash algorithm. Hash mod algorithm, not hash algorithm. So it will compute hash for each order ID and then does mod on using 16, and based upon the remainder, it will move data into its corresponding bucket. Okay, so let me create these tables as well. So instead of date dimension, if you want to just join orders and order items on order ID itself, by using bucketing, the partition pruning can happen, and the performance might be better. Not only for joins, but also if you just want to query on order IDs on some criteria, even then the bucketing can be handy, or hash partitioning can be handy. Now I am creating those tables. Okay, and, I saved it. So I am syncing it. I am going to my virtual machine and refreshing it. And I already created an orders bucket. Now I am creating orders item bucket. Okay, and then the remaining tables. Create table products. So we are done with the ODS table, and now we have to data model the EDW tables. So when it comes to data warehousing, you have to follow you have to follow dimensional modeling. In that, you should create a dimension in such a way that either by using star schema or snowflake schema. I'm not going into details about what is star schema or what is snowflake schema. I'm using star schema. So if you look at this table, it is called as products dimension. And if you look at actual products table, it has only product details, and then there is a child column called product category ID, which is child of categories table on category ID, and then categories is a child table for departments using department ID, and here is the department ID. So if you create using snowflake schema, you will see three dimensions: one for department, one for categories, and one for products. I am using star schema, so there is only one dimension, and then I have product category name and product department name directly here. So when I actually run reports starting from product name and then rolling up to category and department, I can use this table alone to roll up. So that is about the product dimension. And order fact, so I'm storing order ID because order item order ID is the key for the fact table. And also I'm storing date if in case I want to generate reports based upon date. Then I have the product ID, which will be referring to the product ID in the dimension. And then there are some numeric values like quantity, subtotal, and product price. These are called as metrics. So using this information, you can actually see the performance of your products or categories or departments based upon quantity or total or product price. Product price is not relevant for the performance, but using you can actually quantify the performance of your department or categories or products based upon quantity they have sold, or based upon the amount of revenue they have generated. And we have to partition this table In this case, again, after thinking too much partitioning versus too little partitioning, I am partitioning at department level. In some cases, you might have to partition at category level. Okay, and there are certain data warehousing principles which you need to keep in mind while designing the tables. To keep it simple, I am not going into details of those. So let us create these tables in our another database called EDW. So first we have to go to use retail EDW. Okay, I have already created the database, so I'm not running the create database command. I'm directly running these things. So show tables. We have created dimension table in EDW, and fact table we are creating now. Okay, show tables. Similarly, if you do use retail ODS and if you type show tables, you will see the list of tables which we have created. So this is about the physical modeling for our ODS and DDW. There are I will not be able to cover all the scenarios, but I am trying to give the rationale behind designing your ODSs and DDWs for your enterprise data warehouses if you want to implement them in leveraging Hadoop ecosystem. That being said, that is it about Hive DDL. So we are done with Hive architecture and Hive DDL. And as part of the next video, we will talk about extracting and loading into Hadoop. We will talk further on this in the next video. So I hope you are enjoying the series so far. If you like these videos, please click the like button on these YouTube videos. It will give a lot of value for my YouTube channel. And if you are not subscribed yet, please do subscribe to my YouTube channel, which is called as Technology Mentor, and also follow me on Facebook by liking ITversity page. So okay, this is my Facebook page. Thank you very much.